Here, you're asked to express concentration as a molarity. Molarity can be defined as moles of solute over liters of solution. Just another way to express concentration. Here, we're not given moles, but rather grams. We're not given liters, but rather milliliters. So we need to convert those two things first, and then plug them into the equation. 10 grams of NaOH over 1 times 1 mole of NaOH per 40 grams, that's the molar mass, means that we have 0.25 moles of NaOH. 320 milliliters of solution times 1 liter per 1,000 milliliters means that the solution is 0.32 liters. We can now plug those units into our molarity equation, 0.25 moles over 0.32 liters, and find that the molarity of this solution is equal to 0.78. Another way to phrase that is the concentration of NaOH equals 0.78 molar. The next part of the question asks us how many moles of NaOH are contained in 35.2 milliliters of a 0.15 molar solution. Let's rewrite our molarity equation. Here we're asked for moles, not molarity, so I'll solve for moles and then plug in some values. Molarity is 0.15 molar. Molarity equation is in terms of liters. I'm given milliliters, so I'll need to convert my milliliters to liters. Doing that math, I find that I have 0.00528 moles of NaOH. However, you can't measure that in the lab. The question also asks for grams, which is something you can measure in the lab. To convert from 0.00528 moles of NaOH to grams, I'll put the mole value over 1 and multiply by the molar mass. That gets moles of NaOH to cancel, replaces it with grams, and I find that in that solution there are 0.2112 grams of NaOH. Part 3 of this question reads, you want to dilute a 0.15 molar solution of HCl to 0.042 molar. If you want 55 milliliters of the dilute solution, how much of the stock solution should you use? How much water would you need to add? Recall that our dilution equation is M1V1 equals M2V2. Here, I'm given an initial molarity, I'm given a final molarity, and I'm given a final volume. So I want to solve for V1, how much of the stock solution I should use. Let's isolate that variable and then plug in some values. V1 equals 0.042 molar times 55 milliliters over 0.15 molar. That gives me a V1 value, or the amount of stock solution I should use, of 15.4 milliliters. The second part of the question reads, how much water would you then need to add? For this, I know that I want 55 milliliters of total solution, and I know that 15.4 of those milliliters come from my stock solution. Therefore, the difference between those two, or 39.6 milliliters, is the water that I need to add. Another way to look at that is that my final solution is going to be made up of 39.6 milliliters of water and 15.4 milliliters of stock.